1.1 Rectangular Coordinates, Graphing Utilities, Intro to Graphing Equations. This is a Cartesian plane. In a Cartesian plane, there are two axes, the x-axis and the y-axis. The x-axis is the horizontal axis, and the y-axis is the vertical axis. This point right here, that's the origin. If it were to be written in an ordered pair, or if it were to be given coordinates, it would be written parentheses 0, 0. All coordinates are given the numbers they're given based on their relation to the origin. Therefore, this point right here would be written as 2, 1, because it is 2 to the right, the positive direction, and 1 up, the positive direction also. If you had, say, a coordinate right here, it would be written as -3, -3, because it is 3 to the left, the negative direction, and 3 down, also the negative direction. Now, if you had a point right here, that would be written as 2, -2. 2 to the right, positive direction, and 2 down, negative direction. As you can see, the first number always relates to the x-axis, and the second number always relates to the y. The two axes divide the Cartesian plane into 4 parts. There's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, it is both the positive x numbers and the positive y numbers. In quadrant 2, it is the negative x numbers and the positive y numbers. In quadrant 3, it is negative x and negative y. And quadrant 4, positive x, negative y. Now say you need to find the distance between 2 points, one at 2, 2, and one at 4, 3. What you're trying to find is the length of this line right here. Seems impossible, doesn't it? But if we were to use the Pythagorean theorem, and we were to add some more lines in here, one right here, one right here, this would be the y height, and this would be the x height. Now, we have a right triangle, and we can use the Pythagorean theorem to find the length of this right here. The coordinates of this point is 2, 2. The coordinates of this point is 4, 3. The coordinates of this point right here is 4, 2. If we just count, this x equals 2, and this y equals 1. So, from the Pythagorean theorem, a squared plus b squared equals c squared. In order to find c, since we already know a, 2 squared plus 1 squared equals c squared, which means 4 plus 1 equals c squared. Square root of 5 equals c. Pretty easy, right? But, seeing as this is precalculus, we need to find a formula for this. The equation is the one shown above. D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. x1 and y1 are from this coordinate. x2 and y2 are from this coordinate. This point has the same x coordinate as x2. and the same y-coordinate as y1. Now, I won't go into details as to why this works, but just remember the distance formula, memorize it, as you will need it. Now, what do you do if you need to find the midpoint of a certain line segment? This is where the midpoint formula comes in. In order for a point to be the midpoint, the vertical length and the horizontal length of the two segments must be the same, which means that x minus x sub 1 and x sub 2 minus x must be the same. So if you were to set those two equal to each other, x minus x sub 1 equals x sub 2 minus x. 2x equals x sub 1 plus x sub 2. Which also means that 2y equals y sub 1 plus y sub 2. Now, in order to find the coordinates, you have to first isolate it. Therefore, from the 2x equals x sub 1 plus x sub 2, you will get x equals x sub 1 plus x sub 2 over 2. And from that, you will get y equals y sub 1 plus y sub 2 over 2. These two will then form the midpoint formula. M equals x comma y, which is x sub 1 plus x sub 2 over 2, and y sub 1 plus y sub 2 over 2. So far we've learned two equations. The distance formula, which is d equals the square root of x sub 2 minus x sub 1 squared, plus y sub 2 minus y sub 1 squared. And the midpoint formula, which is m equals x sub 1 plus x sub 2 over 2, comma, y sub 1 plus y sub 2 over 2. Now, how do we determine if a point is on the graph of an equation? So, say you take this equation, 3x minus 2y equals 6. In order to check if negative 2, 1 is in it, you plug it in. Since this is the x-coordinate and this is the y-coordinate, you plug negative 2 into where x was and 1 into where y was. This simplifies into negative 6 minus 2 equals negative 6. However, negative 8 does not equal 6. So let's try it again with 2, 0. You've got your 3, plug in 2 for x and 0 for y. Then this simplifies into 6 and this simplifies into 0. Yay! 6 equals 6. So now we know that 2, 0 is indeed a point on the graph of the equation 3x minus 2y equals 6. Alright, so what do you do if you're given an equation but you don't have your calculator? This is why we need to know how to plot a graph using just by plotting points. So, make a table. There's your x, which you would plug into negative x plus 3, from which you get a y. So, say your x's were negative 2, negative 1, 0, 1, and 2. Negative 2, if you were to plug it into here, it would become 2 plus 3, which is 5. Negative 1, same thing. 1 plus 3, which is 4, and this would just be 0 plus 3, so on and so forth. So then, what do you do with these points? So now that you've got these points, what do? You take them and you plot them. So negative 2, 5 would be right here. Negative 1, 4, 0, 3, 1, 2, and 2, 1. See that it forms a straight line. And this would be the graph of the equation y equals negative x plus 3. However, you're not always going to be given an equation that was written like the one before. Sometimes you'll get something like this. 3x plus 3y minus 2 equals 4. So, what can you do about this? First, you have to transform the equation. What we want is to isolate the y. This way we can plug it into our calculator or plot points using it. So, first step, minus 3x from each side. This way you get 3y minus 2 equals negative 3x plus 4. Now you add 2 to each side. 3y equals negative 3x plus 6. In order to get the y by itself, divide the whole thing by 3. Y equals negative 3 divided by 3 is negative 1, therefore negative x. 6 divided by 3 is 2, plus 2. Remember to divide every single part. So in this case, there's 1, 2, 3 parts, and you have to divide all 3 of them by 3. And there you go. Here's your equation, which you got from this. Much neater, right? Intercepts are the points where the graph touches either the x or the y-axis. So you see these black points, every single one of them are intercepts. Depending on which axis they touch, they would either be called an x-intercept or a y-intercept. So since this is the x-axis, these 3 points who touch the x-axis would be called x-intercepts. And since this is the y-axis, these 3 would be called y-intercepts. So, if we were to list the intercepts, the x-intercepts, I'm going to write int instead of intercept, would be negative 3, 0, 3 and over 2, 0, and 4.5, 0. Notice that they all end with a 0 for their y. And your y-intercepts would be 0, 3, 0, negative 4/3, and 0, negative 3.5. Notice that these all start with a 0. This is because when you have a y-intercept, the x must be 0. And when you have an x-intercept, the y must also be 0.